Okay. Well, I guess I haven't used this system before, so I could just normal.
Yeah, just
Okay.
normal.
Okay. So I guess let me introduce myself. I'm Steve Peralta. I'm the Director of Engineering Student Services. I work with all the incoming students, all the students that are actually interested in engineering or computer science or construction management, since we have that as well. But we work with our office works with all those students that are coming in, transfer students, anyone who kind of expresses an interest in engineering, and then we kind of have to figure out or filter them into the right spot. So some of them stay with us for a little while, some of them move on to the department. Just depends on kind of what everybody is interested in. So I guess what I like to do is kind of get a gauge here first. What all are you interested in?
Mechanical engineering.
Mechanical?
Mechanical or electrical.
Okay.
Mechanical.
Okay. Mechanical?
Electrical.
Electrical or computer engineering or computer science?
Computer.
Computer engineering? Okay.
Material science.
Okay.
Mechanical engineering, maybe material science.
Okay. Good deal. What about you up here?
Mechanical civil.
Mechanical civil. Okay. Pretty closely related.
Computer engineering.
Okay.
Geological engineering.
Okay.
Mechanical.
Nuclear. Wow, one. One in the group, right?
Biomedical.
Biomedical.
Civil.
Civil.
Electrical.
Electrical.
Mechanical.
Good deal.
Mechanical or computer engineering.
Okay.
Mechanical.
Okay. Okay, great. Okay. Well, my degree's in electrical, so I have a degree in electrical engineering from UNM. I'm a native of Albuquerque, grew up, born and raised here, went to UNM, finished up my bachelor's degree at UNM years and years ago. I like to say 10 years ago, but I can probably multiply that by 3. And finished up my degree, went on and got my master's degree at Purdue University and started working in the field. Loved my job, actually thought it was fun. I was more of a computer engineer than a double E, and then missed home. So came back to Santa Fe and actually started working at Santa Fe Community College for about 11 years. I expected to be there 1 year. I thought I'd get a real job instead of teaching, and I ended up loving it. I thought it was the greatest thing ever. And so now back at UNM, and part of a program where we help support all of our students kind of getting through the program and making sure that they finish up their degrees and hopefully move on to something that that they want to do, regardless of whether, you know, I took a different path. I don't consider myself necessarily an engineer, even though I'll talk about, I think, a little bit about what I learned getting my degree, and I think what's benefited me the most and kind of helped me, and what can kind of help you as well. So I'm going to kind of go through this. I have a few slides that I do want to talk about. And I want to kind of give you a general idea of things. Please, as we go through, ask questions. You know, there's a lot of material that's here. And most of it kind of related to engineering, and of course, obviously, a lot of it related to the university. And so, you know, I love UNM, not just because I worked there or graduated from there, but, you know, going to UNM and going to a school like Purdue, which is supposedly, you know, one of the best engineering schools in the country, I never felt that I was any different than any of the other students. So it was a very different experience and a good experience overall. So it was something that I think a lot of students, you know, can really gain from, especially if you get to that point. So what's important about these slides here is this is what you could do if you come to UNM. So this is not what you would be doing once you graduate or once you're done. This is actual projects, research that faculty are doing nowadays. In electrical and computer engineering, of course, I'm going to start off a little bit first. Power, plasma, high-performance algorithms, there's high-performance computing, there's the Mind Institute. You actually might have heard about the high-performance computing. It's actually been in the paper the last couple of days. Anybody hear about the new computer that UNM inherited? So one of the fastest computers, they actually have a much faster computer. They're, as it said in the paper, they're getting all the wires together and putting it all together. Lots of processing, lots of memory, just lots of speed. And the benefits of it, computer engineering, computer science, data, so that would be the science department, which would probably be biology, chemistry, some of those areas as well. But just a lot different computing power than what we've had. You may not realize it, but UNM's actually has one of the fastest computers already. This is just going to speed it up a little bit. And there's 2 other of the fastest top 5 computers in the state of New Mexico. Where do you think those 2 computers are located? Sandia and Los Alamos. And Los Alamos is trying to sell theirs. Theirs is near the bottom of the top 5. They want to buy one that's even faster. And so looking at that kind of power and speed, that's stuff that you can work on right from the very beginning if you're interested. We have a really neat robotics lab. The robotics lab is cool because best thing about it, I think, are the flying robots. So we have, of course, a lot of the ground robots, which are very typical. Flying robots, you get a chance to be able to maneuver them around. They can synchronize with the ground robots. They do it to music. They do some fun stuff there, too. But really, I think the most important thing, if you're interested in kind of figuring out how your mind works, there is a psychology major who's getting his PhD in electrical engineering. Kind of weird. But that's what he wants to do because he's actually trying to figure out and work with putting on a set of headsets, you thinking about what you want the robot to do and it responding. And it's already doing it. So it's already actually responding to it. They're really trying to make it so that it's a little bit more sensitive and exactly what they can kind of figure out. That ties in directly to the Mind Institute, which is where they actually take a bunch of people, do a bunch of tests on people, nothing major, but do a bunch of tests on people and just see how your brain reacts. What do you think that type of technology could lead to if they can figure out how your brain is responding to certain types of stimulation? Handicapped people, that's one way to do it, right? So that's one way to be able to respond back to it. So maybe they can find patterns that they can actually respond to. That's correct.
Remote control robotics.
Remote control robotics. And that might be same thing, kind of the same type of issue, right?
Controlling a vehicle, maybe a jet or something?
Maybe something like that, correct. Correct. And then also just making a computer respond the way a human does, right? So artificial intelligence.
You can do art.
Right, and you could even do art. And I want to talk about art when we get to civil, and I want to really show you how a lot of people think that engineering is not a very artsy type of degree, but I'm going to kind of differ with that. So we'll see what you think in terms of some other stuff. Of course, communications, I took out my cell phone. Anybody have more than one cell phone? Yeah, me too. So, back in the day, I remember most people didn't have even one cell phone. Nowadays, I've got my work cell phone and my home cell phone. And I still have a telephone, one of those little corded telephones, if anyone knows what that looks like anymore. But I still have one of those at home as well. And it's just communications. And your cell phone is not really being used to talk anymore. It's really being used to process things, right? Getting on the internet, texting, anything that you can possibly do with your cell phone, that's really what's kind of going on. So you see it cropping up in a lot of computer engineering, electrical engineering types of programs because that's what they're working on. So some interesting stuff here. This is actually from movie pictures and actually the Titanic when they were going through and doing a lot of the animation in a sense, even though you may not realize it was animation. But a lot of the movements, how they were actually going through and showing the ship at any given time. Just some electrical circuits, nothing really major up there. Plasma lab, there's actually a plasma lab downstairs, a robotics lab, that's part of the robotics lab. Some other stuff that students do as well. Civil engineering. So this one here, I think, is probably the most, the type of degree that I think that you see the most. Obviously, buildings, structures, infrastructure, anything that you can kind of think about that you see usually that's out there, some kind of civil engineer had a hand in it, whether it's like in this particular case, this particular building. And as I mentioned, I like to talk about the artsy side of it. Someone kind of has to think about what they want the building to look like. A lot of times the architect has to kind of imagine that. And then what does the architect do? They say to the civil engineer, this is what I want it to look like now, what? You build it. And the civil engineer has to figure out the physics, has to figure out everything around it to make sure that that building is going to stand up. So when they were building this particular building, you kind of think about it, they had to think about what kind of issues when you're building a classroom at a university or at an institution. What do you think they're thinking about? Capacity, right? How many students are going to be in the building at any given time? That's one thing they have to think about. What else? Accessibility. What was that? Sound. Okay, that's right. They do have to think about sound. Lighting. Equipment, tables, computers. Back in the day, back in the 80s, do you really think that they thought a lot about how many computers they were going to have in the building? No, they had probably one computer in the basement, and that's about it, and that's where everybody went. I remember doing that. And so not really a lot of equipment, at least not that type of equipment that they really had to worry about. So they had to kind of think forward and think what it is that they're doing. Even now when they're building a building, who knows what the technology or what kind of equipment's going to be out there 20 years from now and what's going to be available in a particular classroom or anything like that. So that's the construction side of it. Asphalt and concrete labs, we have some really cool stuff that they can do there. We have these freeze and heat rooms where students can actually go in, and in the morning they can actually bring in some asphalt pieces, freeze it to really cold temperatures, negative temperatures, and then the next day turn it all the way up to 115 degrees and see what happens, right? So you want to see how much cracking there is, what goes on with the asphalt and the concrete, how it's actually going to kind of work together. And that's really important, especially in New Mexico, because we get those extremes, right? And even this week, what was happening in Roswell. You think about Roswell, 90 degrees earlier last week, right? And already now this week in the low 30s. And so they really have to think about what's going on and how all that's going to interact. Hydraulics, environmental. There's a really neat environmental side. I didn't really know how big it was at UNM until last semester, so we had a tour with an environmental engineer. He's actually a civil engineer. And we have this flood control lab downstairs where they can kind of simulate arroyos and simulate rivers. And one of the things that they're concerned about right now is the bosque. And if you don't know anything about what's going on there, you hear about the silvery minnow. A lot of people don't think it's a big deal, right? Who cares? It's just a fish. But it's a really big part of the ecology and what's going on with the river and what they're concerned about now. Does anyone know about cottonwoods and lifespan or anything like that, and how they regenerate? So this is what I learned. This is what I thought was really neat, is that the way that the cottonwoods actually regenerate is that flooding every 2 years always happened on the Rio Grande. And so what would happen downtown is that we would get a flood back in the 30s and the 20s. Every 2 years there would be a flood downtown, causing a big problem. So that's why they started damming up. Diking basically is what they did on the river to make sure that there was no more flooding. So the trees at the time all were kind of growing, starting up in the 1940s, and now those trees are about 80 years old, right? Lifespan of a cottonwood is about 100 years old. There's been no major flooding in the area, so guess how cottonwoods actually grow? They grow by flooding. So what happens is the water comes in and regenerates the soil, and actually all the seedlings get watered that way, and that's how they grow. There is no new growth going on there at all. So in the next 20 years, if we don't do something about it, all those trees are going to die. And we're basically going to have nothing in that particular area. So what engineers are trying to figure out to do nowadays is figure out how can we flood that? What can we do to actually artificially flood that without hurting any of the houses that are in the area, anything else around that, but we have to make sure that that actually stays the way that it was. So we kind of did an engineering thing that ruined it. Now we have to figure out how to create that again. Yeah.
Can they build the houses over the water, kind of like Venice?
They could, but then they had all those possibilities of what different types of floods come through, and they really couldn't really tell exactly what was going to happen. I mean, we had almost a flood event back in September, right? Didn't they say that the banks might actually overflow at that particular time? That, for the environment, probably would have been a good thing. And so I think a lot of them really kind of feel like they missed a chance, but that does happen. So yeah, what else could they do around that to be able to create that? But they've already built the buildings there, so what can they do nowadays, right? So not a whole lot that they can actually change. Water resources, water treatment. What's important, I think, about civil engineering, and a lot of times, you may not hear it, what do you think is the one thing over the last 100, 200 years that has allowed us to actually increase our lifespan? What is the one thing? One thing that we did? Clean water. Clean water is the one thing. Not medicine, which helps. I mean, that's going to help you, of course, to be able to recover a little bit faster, but not increase the lifespan as much as what water has done. Clean water is the thing that's really made a big difference. And if you look back over the last 200 years, lifespan of 40 years versus 80 years, huge difference in terms of what clean water can actually do. And so a lot of water treatment. We're really trying to find other water resources, especially in the Southwest and the southern part of the United States. You may not realize it, but Florida going through the same kind of drought that we are. It doesn't show over there because they get a lot more water than we do, just not nearly as much as they should be getting. And so they're concerned about their water supplies down there as well. So a little bit different issue that they have to deal with as well. California obviously going through a lot of issues, even though in the last week they got what, probably a year's worth of water in just a day or two, and so that's not a lot. I mean, that's not very helpful, just like it wasn't here. So same kind of thing that unfortunately can happen. So as I mentioned, an architect says this is what I want it to look like. A civil engineer has to build it. And so the reason I kind of point this out is because this room is perfect. I love it when they do this to me in these kind of rooms. But look at that post right there. Do you think the architect said, hey, let's put a post right by the window? No. But the civil engineer said, this building is not going to hold up, or the rooms aren't going to hold up very well if I don't have a post sitting right there. And so they have to kind of figure it out. It's not even in the corner, which they might have been able to do, but just based on how they did the layout and all of the physics behind it and everything else that's kind of in the building, that's what they had to decide what they wanted to do. And so that's critical. You're also hearing nowadays that architects are kind of being phased out because really just a civil engineer is pretty much going to do their job. Because a civil engineer has to be that artsy and understand how they want it to look as well. Sandia Tram, I'd just like to point that out as a really great civil engineering feat, and the reason that I like to do that is because how many times have you heard that that's fallen? Never. 50 years old. Pretty much the same technology. The wires are a little bit stronger nowadays. That's about it. Everything else is running pretty much exactly the same way that it did 50 years ago. And so I think that it's important to see that a lot of times, sometimes you do actually perfect something. You can make things a little bit better, but not necessarily all that much better in terms of how they actually work. On the right side is the Rio Grande Gorge. That at one point was one of the longest and tallest structures in the entire country. That moves when cars actually drive along it. You aren't going to feel major movement. You're not going to go flying off when a car goes across it. But you will feel the vibration. It does that on purpose. And why do you think it actually moves? Earthquakes, one thing. There are a few more earthquakes up in that region. Thermal issues, right? Heat, things are going to expand and contract. That's correct. One other thing. One major thing up there. The wind. Lots of crosswinds. And so the crosswinds coming through, hitting it from both sides, can tend to want to break, to move it, to bend it. If you ever look up a great video, look up the Tacoma bridge, the one that was opened, and the day that it opened, it actually, crosswinds came in, and you see people running off the bridge, and it collapsed. And so they have to take that into account. This here is, of course, a staircase that's leading up to a place where the nuns went to go up to sing. Anybody know where that is? In Santa Fe. And I really like this because it really shows, what kind of, again, what an architect can kind of think of. There are no posts in here, right? No nails, if you actually take a look at that. A very strong structure. They don't let anybody up it anymore. Obviously, they don't want anything to happen to it. But when the nuns prayed, they used to have to go up on the ladder to get up there to the top, and they prayed, and somebody came in. And the myth is that it was St. Joseph. So I always call St. Joseph the first civil engineer, right?
What does that mean, career path to management?
Sorry about that. That's one of the things, if you're interested, law is actually if you're interested in law, civil engineering is usually the best route to go, because a lot of times you're working in the environment, you're working a lot with the infrastructure. And so patent law, you see a lot of civil engineers that finish up their BS and then move on to patent law. Management, obviously you're going to be managing work sites. So we do have a very strong construction management program, and we even have a construction engineering program. And so those people will actually go through and do something a little bit different than just actually doing the engineering work. And that tends to be the most common, at least, a lot of times. Computer science. This person here is actually the reason why he's got all the lights and all the sensors on him is as he moves around, the computer actually figures out how his movement is and creates animated characters that move exactly the way that he does. What I like to point out, go watch Toy Story 1, right? Great movie, lots of great animation. I think the way that they did it was really innovative, so they did a lot of stuff. But if you really look, you can see that it's all digital. So it was actually created digitally. If you look at Toy Story 3, you'll see that the characters move more people-like, and that's how they actually created a lot of the animation, was movement of somebody else actually moving around. And so you see a little bit a different type of movement in the two movies. So technology, as they go through, that's one big thing. So animation, digital media, really important. parallel and distributed computing. We have molecular chemical computing, quantum computing, so a lot of data analysis that you can kind of see up here. Artificial life, I kind of talked about that with the computer engineering side. Computer vision systems, I'm going to show you something and talk about that a little bit more. And then information systems analysis and security. Security's big, so not only just securing data, right? Target, NSA, all those are famous things that have happened over the last year. And then also just the computer system, just people coming in and stealing your computers and taking them and doing whatever it is that they want with them. You have to be kind of careful. How secure do you think our data can ever be? Never will be perfect. You know, I find it fascinating that people are actually shocked by what the NSA is doing. So, you know, as an engineer, I always thought that's what they were doing anyway, so to me it wasn't a big deal. I mean, I was more shocked that somebody actually came out and admitted it more than anything. But really a lot of information you have to be really careful about, and especially when you start looking at cell phones. You know, your computer's probably a little bit more secure because you can secure it a little bit better. So not maybe as much information kind of traveling around, especially if it's just kind of limited to your own computer. Cell phones are a different story. They're pretty open. And because they connect to a lot of mobile networks, because they're connecting to each other, because you're actually sending stuff out, right? And I think another funny part is Snapchat. Anybody who use Snapchat? So I think it's interesting when you send pictures out and you think, well, it's going to disappear in 8 seconds and no one will see my picture out there. Well, yeah. Okay, the company actually even has already admitted they save the pictures for what, 4 months? And that's what they do. And then you can imagine if they're saving the pictures, who actually has access to that information as well. And so you have to be really careful about what you're sending out. So always just watch that kind of stuff. So I would just tell people you really have to think about this day and age, things really aren't nearly as secure as you want them to be. Students that have actually created some animation up here, so I think some innovative pictures, movies, things like that. This looks like the head of Phineas and Ferb, if you watch that or anything. If you've ever seen him bouncing around. This here is actually face recognition. What do you think that could be used for in the future? Or what it's even being used for now? Security? Where? Airport. And that's actually one big thing that they're doing. Pardon? Government agencies. Even in some cases, right, when they were looking out in Boston, when they had the bomber out there, what were they doing? They were actually reviewing a ton of film. And they found video of people that were going through stuff because of what they could recognize. Some cases, those cameras weren't exactly set up for any kind of face recognition, but some of them were. And so being able to actually go through and figure out, okay, who's out there and what's out there. But think about the technology if it were to come to ATM machines where you could walk up to an ATM machine and instead of putting in a card or a code, it just recognized your face and then gave you access to your account. Okay, a little bit nicer to be able to do that. You don't have to carry around your wallet, and you don't have to worry about anything getting stolen except somebody, chopping off your head, right, and carrying it over. Okay. Yeah. That's about the only thing I could think of. Mechanical engineering, strength of materials, vehicles, gearing, fluid mechanics, robotics. This is more of the movement of the robots. Solar, they actually take care of all the solar panels on top of the ME building. That's the undergraduate students do that. Heating, ventilation, refrigeration, biotechnology, so there's a really close tie to the medical school in this area too. And so what can we do? Artificial limbs, artificial hearts, snowboards, if you want to kind of create the next generation of snowboards or skis or anything like that, and that's again all that movement, a little bit of civil in there. And I think what's important is you're going to see that kind of cross with mechanical and civil every single time you're seeing a lot of these different types of examples here. Vehicles, from bicycles to cars to rocket science, as we say. FSAE, has anyone visited UNM and seen the FSAE program or the FSAE lab? So students actually get to design and build their own FSAE race car, and they actually race it. And believe it or not, the shorter you are, the more likely you actually get a chance to drive the car. So, because it's just the way that it's built. So that's just the way that the car is built. I like to show these machines. You can see the car here, and you can also see, of course, that huge machine there. That's relative to that. They might have to be going in and maybe digging out some rock or putting up something where they need to get into. So designing that type of machine, sometimes you get excited about that, right? Remember when you were a kid playing with all the little toys and everything that you had? And so I think a lot of times that's the kind of fun stuff that you get to do. All the way on the other end, that's a nano gear. That's cell-like, so you really can't see that with the naked eye. You actually have to have a special microscope to see that. NASA was actually building, when a student was out there from UNM, chemical engineering major, oddly enough, even though he was kind of working in the mechanical engineering side, but it fits what he was doing, is that the astronauts, instead of taking up a bunch of pills up into space, so if they get sick, if something happens, they need to take medication, what they would do is medicate or inject an astronaut with a little cell. It would actually travel through his body, find the cells that are sick, and just medicate those. Yeah.
I saw something similar like that in a documentary called Transcendent Man.
Mm-hmm.
This guy took nanotechnology, just like supplements, like you're talking about.
Right.
And it reversed his type 2 diabetes. He was able to cure himself.
Really?
Designing the nanotechnology and then
Right.
ingesting it.
Right. And so to me, that's where you're kind of seeing the technology go. And so and nanotechnology, I haven't really mentioned a lot of nanotechnology, but along all the different fields, you actually see that kind of appearing. And so I think that's something that you can kind of think about. In civil engineering, it's all about, building stronger materials, things like that. In the gearing side, on the mechanical side, it's about building these little cells or these little motion figures, whatever it is that we need to do so that we can do something, whether it's medicating people or doing something that we need to. The chemical engineering side looks at that side of it, right? Being able to help people, if you're interested in the pharmaceuticals. And so there's all kinds of different applications that you can kind of see over here. Seawater into drinking water, you may not realize it in New Mexico. In the Tularosa Basin, we have enough water to give to about 2 million people for 100 years if we could figure out how to get the salt out of it. So we have a huge supply of salt water in New Mexico. And the problem is it's just too costly, not only costly to pull out the salt, but costly to figure out what to do with the waste. San Diego actually has a saltwater treatment plant, so they pull water out of the ocean, and that's how they actually supply a lot of their drinking water. But again, they run into the problems of what are we going to do with the salt? How are we going to dispose of it? What exactly can we potentially do? So an issue that, again, engineers have to kind of think about. How are we going to be able to solve this in the future? Roller coasters, that's that civil mechanical side again, but of course it's the movements. That's why the mechanical engineers prefer it. Any kind of gearing, very, very small. So we're seeing, iPods, anything else that's even smaller. You're just seeing really small machines. Robotics, again, as I mentioned, kind of the movement. And then on the bigger side, on the medical side, MRIs, anything else that you're doing with the machines themselves. So a lot of ties there with mechanical as well. Chemical and nuclear, we have petroleum, which is oil. Big thing that people want to go into in the oil field or in the oil industry itself. And so they need a lot of chemical engineers. If you're interested in petroleum engineering, I always say get the more broad chemical engineering degree, take a few classes in petroleum, and you've got exactly what you need. But it makes you more diverse. Food and food preservation, pharmaceuticals, artificial fibers, petrochemicals, plastics and ceramics, environmental protection, process safety, biomed. So there's where the biomed first kind of appears, but the biomed was kind of hidden in the mechanical side, and there's also biomed in the electrical side. So it depends on what part of biomed that you're interested in. Do you want to work on artificial limbs? Do you want to work on the pharmaceuticals? What is it that you exactly want to do on the biomed side? Hazardous waste management, fusion and fission on the nuclear side, and exploration and utilization of outer space. So pretty much the only way that we can travel in outer space is with nuclear fuel. Obviously, solar would probably be the next best thing, and that's probably what they did back in the day. But if we have any kind of spacecraft that's going to go out of our solar system, all of a sudden we lose the sunlight. No more power. So a big deal. On the nuclear side, we have, so you can see the nuclear power plant. We actually have a nuclear reactor at UNM. I don't know if anybody's aware of it, but all the nuclear engineering students get a chance to work with it. If they power it for a week, it'll power a toaster for about an hour. So it's not very powerful, but it is something that's out there. They tried to scare you, when everything happened in Japan on the news, and I saw this, they said, oh my God, we have a nuclear reactor at UNM, and what's going to happen if it does this? And they went and talked to all the professors and tried to scare everybody. And that's when he said nothing can really happen. The person who's handling it might have some trouble later on, but nothing else if anything actually goes wrong. How safe do you think our nuclear power plants are in the United States? Very safe? Not so safe? Pretty safe? So everybody understand what happened in Japan?
Yeah, they got an earthquake, a tidal wave.
So they had an earthquake. So their systems out there are a little bit older, and their safety procedures a little bit different than the United States safety procedures. They had kind of a two system. So they said that if two systems fail, there's a problem. In the United States, all the nuclear power plants are built on a three system type of well, I guess just a system that it works. So if three things fail, there could potentially be a problem. And you may not know it, but remember when the earthquake hit Washington, D.C., and that whole region, the East Coast? This was probably almost a couple of years ago. About a year and a half ago is when it hit. The Washington Monument was damaged, so they had to close it down for a little while. They felt it in Virginia. They were feeling it all over the East Coast. Well, 3 nuclear power plants got hit by that. So they shut down like they should. They shut down, went onto their backup power, and were running just fine. A week later, do you remember the hurricane that went up to the East Coast?
Sandy?
Yeah. No, it was the one before. I think it was even before that. So that one just went right up the East Coast, hit New York City, actually went right across New York City. Guess what? Those 3 power plants all got hit. Didn't hear anything. The reason why you didn't hear anything is because nothing happened. So was it newsworthy? No. So no one really cared, at least at that point. California always gets the earthquakes, right, and always has the problems. They have the most nuclear power plants in this country, at least per capita, and they have them built all around there. So a lot of engineers really have to think about what could potentially happen if something like that did hit. So they're pretty safe. Oil, of course, we've always had problems. See, I love chemical and nuclear because they've been in the news the last few years, so we can talk about them. But you know, the oil rig problem out in the Gulf Coast, of course, chemical engineers trying to figure out how to be able to save that and be able to do that. You may not realize it. Have you seen the sand that can actually repel water? These are in kits, a lot of student kits, and what they can do, you know, you dump them into water and you fish them out with a spoon, and they come out completely dry. And so they like to show this stuff off. That stuff also will attract oil. And so one of the things that they wanted to do, the chemical engineers wanted to do, was to dump a bunch of the sand in to the Gulf and then actually scoop it up in a sense, and it would have collected all the oil. Problem was it was probably about 10 times as costly as what they ended up doing. And so guess what? They didn't want to do it. But the technology is there. So what's important is that you're seeing all that technology and you're seeing everything that's out there to be able to kind of be able to clean up some of the problems that we cause, and the engineers are the ones that are coming up with it. So now your job is to make it less costly, right? That's the whole thing that you guys have to do. So synthetic materials, so we want things to bend but not break. We have fiber optics. So what's important about engineering is that there's a lot of teamwork, lots of presentations and demonstrations, so you always have to show people how everything works. Definitely lots of testing. When I was working for Bell Labs, if anybody even knows what Bell Labs is, you guys have all heard of AT&T, so, but probably not too much so with Bell Labs. But when I was doing testing over there, that was a critical part of the whole job because you want it to fail in the lab, not fail with the customer, right? That's the worst thing that can happen is when it fails with the customer. So our job was to break it, and that was fun. So that's always fun when you're trying to get something to break. Lots of design and manufacturing. And so some important SOE facts that I always like to point out. EE and CompE are pretty highly ranked, 32 and 37. And it depends on the ranking. And what I think is important is to kind of point out how they actually rank things. A lot of times it's the graduate programs. They're actually starting to rank some of the undergraduate programs. And just so that you have a general idea, UNM, just the first ranking that we've seen, UNM came in the low 90s. So the low 90s in terms of all the undergraduate programs at UNM. So that includes everybody. New Mexico State ranked 115th. Then what they put is they put a little footnote and they say the bottom 25 they don't bother ranking. And guess who is with the bottom 25? New Mexico Tech. Yeah. Yeah, and so a lot of people have this misconception that New Mexico Tech has a lot of research going on, and they don't. They just don't have the numbers, they don't have the faculty, and they just don't have the money that most research institutions can produce. So we get about $32 million in research per year. We were ranked number 14 by the Princeton Review. We're one of 2 high Hispanic enrollment universities that are Carnegie, very high research. So that puts us at the very top level of research. So that's how much money that we're getting in. That's how much money the faculty generate for the university, for the School of Engineering specifically. Why does being high Hispanic, how can that help everyone? Because it's a diverse institution. What's important is that you actually studying with a lot of other people, different types of people, whether it's degree people, whether it's ethnicity, whether it's background, whatever it is, that actually puts you in a way different category because companies look for people that know what diversity is like and are used to it. And if you don't understand that, you have to get used to it within a corporation because that's going to be important. Because your customers are different, your employees are different, everybody's kind of different. And so they want that just already kind of inherent. We're we're the only ABET accredited CompE and CS programs in the state, and our ME program actually has one of the highest female population rates in the entire country and the highest graduation rate. So, and so that kind of gives you, again, an idea of when companies come out here actually interviewing and hiring people because of those types of statistics. So that's kind of important for everybody. So to become a general engineering student, you have to be at least at Math 100. That is our basic algebra. So we used to actually only accept students that had completed pre-calc and trig, and for those of you that might have known that from before, that was our old standard. We are now accepting everybody at intermediate algebra and above. So we feel that, and finally the university is letting us do that, we feel that we can advise the student a little bit better if we get them right away, get them into our programs, and get them integrated with the other School of Engineering students. And so we're doing that nowadays. So we used to have, I was just looking at the numbers over the summer. Before we started accepting students, we had about 500 students in the School of Engineering and the General Engineering program, our program. Right now we have 1,136.
So you're accepting them as freshmen pretty much?
We've always accepted them as freshmen, but they had to be at trig and pre-calc.
Right, to be in the...
in General Engineering.
In general engineering.
Right, and now it's lowered to Math 120, which is intermediate algebra.
That's good.
Yeah.
I know that.
Yeah, and this summer we're actually going to be seeing the students at Math 100. So what our hope is that we're going to be able to grab those students too. And so we're starting to be able to show that we can actually handle and work with these students a little bit better and get them graduated. So even if you start off in a lower math, and a lot of students have a difficult time, I think, understanding that, but even if you start off at Math 100, literally you could finish your math and get caught up to Calculus 1 by the time you're done in a year. That's 3 semesters. So if you were to do Math 100 your first semester, Math 120 and 121, we now call it Math 101, 102, 103, and 121. If you're to do those 4 classes, which is 6 credit hours, and do that in the spring semester, then you take trig and pre-calc over the summer, guess what? You're in calculus by that fall. That means you're only a year behind. Now, how focused do you have to be on math?
Ultra.
Yes. And you have to be serious about it. And so what I think is important is that you really have to be serious. I came from, teaching at a community college. I knew students who started off in a lower math. I mean, that's kind of what I think the community colleges support a lot of times, is students who weren't quite as prepared to move into the university, at least not yet. And so our job was to help you get through the math. That was a big thing. At least I considered it my job because I was in charge of the computer science and engineering program. And so I wanted to make sure that the students actually had the math, but you had to get the A's. The A's are critical. How many of you are taking or have taken Calculus 1? Okay, a few of you. Pre-calc and trig? Okay. You don't have to raise your hand, but are there, unless you want to, but the Math 100, 120, 121, that's the basic math all the way up to college algebra. Anybody in there? Okay. What I want to kind of point out, what I think is really important, if you're in Calculus 1, you're going to understand what I'm about to tell you. So I took it and I've taught it. I think Calculus 1 is going to be your hardest algebra class. Because the first 8 weeks you're learning theory. You're learning about how to put everything in the right order. You're taking these limits, right, as x goes to infinity. And then you have to understand how things graph. That's part of the pre-calc part of it. But you have to get things in certain order, right? Everything has to be understood in terms of how your math is, but your algebra needs to be really sharp. Because we go through formulas that use the math that you were learning in the earlier classes. When you start learning integration, you can only do 3 types of integration, right? It has to be in a certain form before you can actually integrate. And so you usually have to do partial fractions. You have all these things that you have to learn to do. And so factoring, all that fun stuff that you didn't realize was going to be that important, and all that stuff is important in Calculus 1. It's very important in Calculus 2 as well, but I think Calc 2 is the hardest calculus class. So there's a lot of stuff that you're doing that doesn't connect. I thought Calc 2 was the worst class ever, even though you learned a lot, but just because nothing connected, you'd be doing one thing in one chapter, and all of a sudden you're doing polar in the other chapter, and then all of a sudden you're doing convergence and divergence in other chapters. Like, how does this even connect, right? So there seemed to be no connection with Calculus 2. Calc 3 I thought was the easiest. Once you get to Calc 3, there's like 3 topics you need to know in Calc 3, and that's it. You go into them in depth, but you need to know those 3 topics. And DiffyQs was even easier, except for the programming. And I teach programming, so I can say that. That's what students stress out the most on, is the programming part of it. So kind of keep that in mind when you're doing that. So if you're in a lower math, don't just blow it off. You need to know it. So if you know it, I guarantee calculus will be so much easier. It'll just be really easy because you'll know all the rules. I don't know how many times, I would recognize that something was a perfect cube. I may not remember how to factor it, but I knew that it could be factored, and so all I had to do was go look it up and see what the rule was. And so, you're not expected to memorize everything. That's not always what's going to happen. Maybe in class, yes, for a little while. But after that, you're not going to go to work and they're going to say, how do you do this? And how do you factor that? And do it right now, right? And no help. Don't look at your computer. Don't ask anybody for help. They're not going to do that. And so trying to understand that and being able to relate it, I think, becomes really important. So what we expect, math, science, and English are all your foundation for your upper level courses. Your skill set, that's what I just talked about. Your skill set has to be developed. So good math, good algebra, good at physics, at least understand it. I'm a double E. I hated physics. I don't know why I went double E, because that's all about physics. And now I can do it. I get it now. Being a teacher, I think, really kind of helps you. So the more you can tutor someone, the more you're going to learn. I guarantee it. Chemistry, so the sciences are important. I hated English, but I know I have to know how to speak and write, even though if I have to do a paper or something, a proposal, I wait till the very last second, just like you guys do, because I avoid it as much as I possibly can. With any other schedule, you can still be successful, may work a little bit harder. As I mentioned, math levels before Calc 1, you're building necessary skills. Persistence. So even if you're at a lower math level, you might have to take a year to do it. And you may not be taking classes that count towards your degree. So what? Get the math done. Doesn't matter, right? Do other things during that year to kind of get yourself prepared so that when you do hit the stuff that you need to get, you're going to be able to dive right into it and be able to finish it up pretty quickly. This is kind of what we expect. 4 hours per credit hour per week outside of class. That's for studying, prep time, and homework. So 15 credits means that you're going to be in class for 15 hours a week, approximately. Multiply that by 5, because the 15 hours you're in class, and then the other 4 hours you're doing other stuff. That's 75 hours per week that we expect you to spend on school. If you do that, you're going to be successful. You're going to be fine. Okay? If you cannot spend 75 hours, what should you do? Okay, lower your load. Sometimes people say drop out. No, we don't say that. So we say, yeah, maybe it's full-time and trying to get 15 hours isn't the best thing for you. And I know that, the lottery's changing to 15 hours. The University, New Mexico, UNM actually has a tuition setup that you take 15 to 18 credit hours, you pay less per credit hour than you do at 12. Maybe paying more is a little bit better for you, because actually having the grades and getting what you need to get done could be better, even if it costs you an extra $200-300. So just figuring out what is kind of the best thing that fits into your schedule, I think, is important. And what I always tell students, and I'm not the best at this, but schedule your time. If you can get a whiteboard at home and you can put up a weekly calendar and put down what you're doing that week, when you're studying, when you're going to class, when you're goofing off, when you're doing everything that you need to do, actually have a schedule so that everything, exactly what you're doing at any given time, you're going to start following that schedule, and it's going to become a little bit more inherent again. And it makes it a lot easier to get everything done. Because then you're going to say, oh yeah, next week I have a test and now I see it on my whiteboard, and you're not worried about it, oh my God, I have a test tomorrow, right? And so it makes a big difference in terms of doing something like that. So we expect adequate progress in your foundation classes. If you're getting B's or better, you're going to finish up your degree program a lot faster, obviously. Overall GPA has to be above a 2.2. Your foundation class is above a 2.5. You can have no more than 9 hours of D's, F's, and WFs. So if you come into the School of Engineering and you have those, there is a potential that you may not be accepted to the School of Engineering right away. It depends on how old those courses are. So we do realize that students, when you first started school 4 or 5 years ago, you were goofing off, you were having way too much fun, and you flunked everything. And that happens. We see it a lot of times. And usually what the dean will do is they'll accept you on probation. We now call it Academic Improvement Program because it sounds better. But it's still probation. But usually for a semester, as long as your grades are good, then you'll just go off of AIP and you're done. And you don't have to worry anymore. 3 attempt rule, you need to finish up your foundation courses, the courses that count towards your degree within 3 attempts. Otherwise, it looks like you aren't going to be able to finish your degree. Obviously, if you're taking Calculus 1 4 times, right, that's over a year of taking Calculus 1, which means you can't go to Calculus 2, which means you can't go to Physics 2, which means you can't go to Statics. All of a sudden, all these courses are blocked because of one little class that you can't pass. So you want to make sure that you're passing your classes. Grades don't transfer, but they are used to determine your admission to the departments. So if you get a bad grade here, yeah, your grade's not going to transfer over there, but when we try to calculate your GPA for admission to the department, it's going to get calculated into it. Now, what we're getting away from is multiple attempts. What the departments used to do is they used to say, well, I took Calculus 1, 3 times. I got an F, an F, and an A. And so they would count the Fs and the A in your GPA calculation, and that would lower your GPA admission. We're getting away from that. We're actually just accepting your last grade and your highest grade. And so we're actually looking at to what you're doing now and looking at that a little bit differently. So that's kind of changing our culture as well. So we have lots of support services to get you through your school, get you through your classes. We have student organizations, scholarship opportunities. We have a computer lab that's available to our students 24 hours a day. We have a really great STEP program, which is our internship or co-op program. We have a WISE program, an A-STEM program, just lots of workshops. So, how to study, how to take tests, how to pay attention in class, how to take notes, that kind of stuff. And those are sponsored by those organizations and open to all of our students. And then some of those programs have scholarships as well. Our student organizations, we have 5 of them: HESO, ACES, NSBE, SWE, and EWB. You can see that 4 of them are gender or ethnic based, but they're open to all students. Professional development workshops, we have career fairs. Graduate schools come out here recruiting our students, and that usually is a good sign for our undergraduate program, by the way. So a lot of times you can tell that you have a good undergraduate program based on where the students go for the graduate school. And right now our biggest feeder is Berkeley, and I don't know why, but they love our students. And if you ever get a chance to meet Dr. Kenny Armijo, who is from Belen, started off in Math 120, and now has his PhD working for Sandia and has 5 of his own startup companies. He's recruited by Berkeley and Stanford. He decided to go to Berkeley. I think he was probably the catalyst for the Berkeley connection. And so we're bringing a lot of students over there and being able to see what's going on there. Networking with industry, scholarships, conferences, lots of opportunities. EWB is kind of a catch-all. They like to go out and do projects in the community, so they bring solar power out to the reservation. What's nice about doing projects a lot of times is that you get a chance to work side by side with engineers from Sandia, from Los Alamos, from Intel, from Honeywell, and so that's usually a good connection for a lot of our students. So our transfer admissions, about 145 last year. 2-year to the department, 2-year to general engineering. So these numbers, they don't seem very high, but believe it or not, they've actually really shot up. So this number of students has gone up quite a bit. What we're seeing this year, and I think what I'm going to be able to show this year, is those numbers are way different in terms of how we're seeing the students come prepared from CNM. Does everybody know about STEM Up?
Yeah.
Okay. That's a really critical program to get involved with because they're very helpful in terms of getting you in. And I love working with them, so they're a great program here. But what we're seeing is that the students from CNM are much more prepared coming to UNM than ever before. And that's great. That makes my job much easier, and then makes it easier for us to advise you and make sure that you're taking all the right courses once you do transfer over. Scholarships, there's the Amigo transfer. NSF, we do have NSF. Most of them are need-based, that's the only problem. Some of them are designed specifically for transfer students, so they look specifically if you're a transfer student, that can help you. Engineering scholarships, the general engineering and departmental scholarships as well, that we actually take care of in our office. And so what's next? Lots of math. Prep classes, you do know you can take differential equations and linear algebra here, right? And it transfers to your engineering program. It will not transfer to the math department. So you're always going to have that trouble with that particular class. The issue is that we're switching now to a 120 credit hour degree program from 128 or 132, depending on the degrees that's out there now. And there is a rumbling that we're going to combine DiffEQs and linear algebra into one class for 3 credits. Just learn the material that you need for engineering, and that's it. Physics, make sure you take the calc-based one. Chemistry, programming, MATLAB, Java or C. However, you should take MATLAB at UNM because I've heard that they have the best teacher in that class at UNM. That would be me, in case you didn't figure that out. UNM courses, if you can take a UNM course while you're coming here, I think that's the best thing for you. So if you can take, the ME 160 if you're a mechanical engineering student, because it's only offered at UNM, take it as early as you possibly can. It's required with at least calculus. That's only because they're limiting the enrollment. But take it while you're here so that you can finish up your 2+2, finish up your associate's degree, and transfer directly as a junior to the engineering program. And so we've worked that out that you can do that. Core courses, they could be a little bit different here. I know that they're asking you to take a few more core classes over here, and plus you have to take that IT 1010, right?
Yeah.
And so those are some courses that you might have to take finishing up. So that's why I'd say completing your associates. I think it's important, not just for you, but I think it's important for the institution. Coming from Santa Fe Community College, that's kind of how they judged us. How many students did you get to finish the pre-engineering program? And we would do about 1 every 3 years. And they thought that was good until they switched over to the new system, which is how they give you funding, right? So they give funding to the 2-year schools based on how many graduates they have. And so that's why you want to give back. They're helping you out, right? You're getting a deal on tuition. You're getting some good classes and some good instructors, except the MATLAB instructor. You're getting some good instructors here. And so you want to give back by giving that associate's degree. And what's good is you can transfer to UNM early, and you can actually transfer courses back to the degree and finish up your degree here, which also helps the community college. And so you want to make sure you do that as well. Meet with us. If you aren't ready to transfer, come over and meet with us anyway. It doesn't matter. We'll meet with you. We'll tell you what you should be taking at CNM. We'll tell you what we think that you could take at UNM if you're ready, and we'll help you transition. Know about UNM STEP a little bit more. And that STEP program is our internship program. That's when you become a sophomore. When you're done with your sophomore year, you're eligible to do an internship with a company that works with us. And then, of course, as I mentioned, know about the STEM Up program. So any questions?
The calcs here, and then do differential equations in linear algebra, or at UNM?
Well, no, you can take the differential equations and linear algebra here, but what I'm hearing on a rumbling is that they're going to combine the classes together at UNM as an engineering course.
So it might be more efficient.
So it might be more efficient. And then we'll have to see how we're going to transfer that back over here. But usually it's not that difficult to do that. But at least we should know by the fall semester as to what's going on with the 120 credit hour degree programs. Because all of them are required to be 120 credit hours.
Also, can you discuss what took you to Purdue and how long you stayed there?
Yeah, so when I graduated from UNM, I hated school. I was tired of it. So what I did is I purposely applied to every single school late. So I waited till their deadline, and then I applied like a week later, thinking I wouldn't get in. Bell Labs was actually paying for my school, so that was kind of, I had to go to school. And Purdue accepted me. And I was like, oh, crap. So I went there, and it was tough. My first semester was the most difficult because I really didn't want to be in school. But what was interesting is that my next semester I really started liking it a lot because I was meeting new people. I actually liked the classes. I felt like I was at the same level with students that graduated from Purdue and were getting their masters there. So I didn't feel like I was any more, you know, you're coming from New Mexico and you feel like you're kind of behind everybody. That's usually what happens, I think, a lot of times. And I started just noticing I'm just like everybody else. And I was learning stuff, and I finished in a year, so I actually had to go to summer school. You know, I just picked the institution mostly because I was trying to pick some of the top colleges. I really wanted to go to Michigan, but I wanted to focus on the computer science side, but they were telling me that I didn't have the background to do computer science. And it was probably better that I did electrical engineering and kind of focused on the computer engineering side of it. It was a great experience, something I could say that I'm glad I did, because if I hadn't, I don't know if I would have gotten my master's degree.
Right.
Yeah.
And then why did you decide to teach?
Well, like I said, I planned on being at the community college for 1 year, and then I was going to get a real job.
Right.
So that was my plan. Was, you know, here I am in Santa Fe. I thought, well, I'll have connections then to Los Alamos, and I'll, you know, find out about what's kind of going on in the technology, maybe Sandia, something in Albuquerque. The economy was kind of bad then, so it was kind of hard for me to transfer from Denver. That's where I was working, and so I thought I'll just be here for a year, and I ended up loving it. It was the best job. I mean, what's really neat if you're an engineer is that you think, what's the greatest thing? Coming into the classroom and having a new group of students every single semester. It's like a new project every semester, and then it's done in 4 months.
Every project.
That's right. Every project is done. And, you know, I teach MATLAB, but I'm always trying to integrate new stuff. Like this semester, I'm buying robots, so our students are actually going to be able to program some robots by the end of the semester. So the TAs are stressing out because they have to learn how to do it. But that's kind of the next step that we want to do. And, you know, the EE department does it, so why can't we do it? So I'm trying to kind of steal some of the ideas from them as well. But I like teaching, and I like the program. I like seeing a student also kind of come through, and, you know, I like working with the difficult students. I love the ones that are difficult, but the ones that are difficult are kind of interesting too, that finish in 6 years, that, you know, failed most of their classes early on, and they're kind of like a project too. They're just a 6-year project. Yeah. Yeah. Yes?
I think you touched on it, but is it possible for, once we transfer over there, do you offer all the classes at night and evening classes to graduate?
Not necessarily. It's always dependent on the faculty. So there's a lot of faculty that only like to teach in the morning. And so that's kind of the option that you have to go with. I would say that once you're in the junior and senior level classes, they're either early morning or late at night. Usually none are in the middle of the day. So faculty are either really lazy or they are early birds. If I had a choice, I'd teach an 8 o'clock class. I'm a morning person. So, but it just depends on what it is that they want to do. So, yes?
Have you taken the engineering exam for licensure, and if so, was it difficult?
I didn't take it.
Okay.
No, I wasn't required to take it, so I didn't do it. No, so I don't know what it's like. I took the GRE, and it's interesting with the GRE, this was back in the day. And with the GRE, the math was easy. The highest you could get was a 98 percentile, and I had a 98 percentile in the math. And the logic, I had a 98 percentile. Purdue didn't care about the logic. They cared about your math and your English. The English, I had a 33 percentile. It actually classified me as English as a second language. I'm like, oh, this is my only language. Maybe programming was my first language. I don't know. That was kind of sad. I had a friend who did EE, and he actually transferred to Purdue as well, or he moved to Purdue for his master's. And so what he did, knowing about my bad grade, is he actually read the dictionary on the bus to work for an entire year. And he did better on the English part of it. So, yeah.
Persistence.
Yeah, and that's what it is. It's all about that persistence, you know, figuring out what your goal is and figuring out what you want to do. He actually works, he was one of my best friends in school, and he actually works at Sandia now as a manager. And so, you know, it's interesting to see people that, you know, you kind of graduated with and where they all are nowadays.
You mentioned startups that some guy at Sandia
Yes.
has. He has 5 startups.
Yes.
What does he do at Sandia, and what are the startups?
Well, his degree's in mechanical. I believe it's mechanical engineering. And so I don't know what kind of work he does at Sandia. But I do know that some of his startups have been clean water in South Africa. So he actually started up a company that actually was building filters, water filters, that people in South Africa or communities in South Africa could purchase at a really cheap price. And so he actually kind of worked on that part of it. So that's one of his companies. He's done technology out in those areas as well. So, you know, being able to create a device that could actually feed off a satellite so they could actually have the technology without having to have anything else installed. So that's another part of it. But he did all that stuff while he was at Berkeley, while he was a student.
And he had less than a, what did you say, he had an algebra?
He started off at intermediate algebra, and he came out of Belen High School. Mm-hmm. Yep.
That's where I'm from.
Yeah. Yes.
How important do you see that with internships and then going up after year, how important is it to get involved with internships and then volunteer work for research projects? Just to get a feel for it.
Well, what I think is important is when you first get to UNM or any institution, regardless of where you go, you know, volunteer right away in a lab that interests you. So find a faculty person that you really want to work with and say, hey, you know, I have 3 or 4 hours a week. Can you put me to work? And I'll work with your GAs, or I'll work with anybody else that I need to get something done. And if you're really good, then they usually will hire you on as an undergraduate researcher. And so I think that's a really important step. I worked for the Environmental Protection Agency my first summer after my freshman year in Dallas, and all I did, see, this is going to age me now. So all I did is we all their paper files we put on the computer. So all I did is just transfer data to a computer. I remember doing that every single day. And I did that for, you know, 10 weeks or how many ever weeks I did that. And then the next summer I went to work for IBM. And IBM had just created the IBM PC. So this is, again, aging me again. I'd show you some pictures. They're very interesting pictures. But it was all they had the Peanuts characters. If you actually look them up, that's how they were all named. And so the technology on that was what, maybe 100K storage. RAM was probably even less than that. But I got to play around with it. So after work, what I would do is I would actually play with the computer after work and just kind of learn how it was functioning and how things were going. So I got to kind of be on the ground floor when the computers were first coming out and seeing how they were starting to interact with the technology and what they were doing. So that part of it was really neat. And I worked for IBM a total of a year. So it was 2 summers and a co-op. And so I had more than a year of experience coming out of college, which meant that I had more choices at jobs. So, you know, I had job offers from Bell Labs in Denver, in Chicago, and in New Jersey. Obviously, I'm picking Denver. And I'm a Broncos fan, so I had to be out there. And then, you know, I had offers from, and it was Martin Marietta, which I think is now Lockheed.
Probably.
Yeah, I think it's Lockheed. And then some other, I think there, you know, I can't even think of all the names of the companies because they're not around anymore. But it helped. It definitely helped, and people who graduated with me didn't have as many opportunities. So I think that's what made a big difference. Regardless of whether it was relevant experience, I mean, did I really do a whole lot of stuff? Probably not. But at least I knew what it was like to work a job, an engineering job. So, and like I said, the one thing that I mentioned about what I think I learned the most from getting an engineering degree is logic. I think I'm a very logical person, and I think that, you know, I think things through. You know, my goal when I'm done with this whole engineering thing or done here at the university, because I can retire in, 3 years from public service, basically from the school system. And I always thought, you know what I really want to do is I want to own my own gym. So I go to Define Fitness, and I think, how illogical is this whole setup? If you've ever been to Juan de Beau, you know, you walk in there and it's like, okay, they have some machines for chest at the bottom and some at the top. So if you're running around and you're trying to get people through, which is what they're trying to do, that's the dumbest setup that you could ever do. And so I think very logically. I'm like, I'd put all these machines together and then I would have real savings. So if you're a student, and of course I think on the education side, if you're a student and you have an a 3.5 or better, I'm going to give you a great discount to join the gym. Because two things. Number one, you may not be there as much because you're studying all the time, right? But also to reward you, because I think it's important to do that kind of stuff, and then have a real tie with the schools, and being able to offer the athletic teams certain times to be able to go in there. The older folk, do the morning stuff and give them a cheaper rate as long as they're going between 8 and 12 in the morning, and all this stuff that you can kind of set up. So I just always think that that's how I think. I just think very logically. And I wonder why they, how they're in business half the time because of how illogical I think it is, obviously. And so that's kind of what I think I learned the most out of school. How to be able to figure stuff out, how to be able to think, and how to be able to kind of analyze something that's going on, whether it's engineering related or not. And that's how engineers have to do it. I mean, in all honesty, do you think that 20 years ago that anyone could have just said, this is what I want a telephone to look like? Right? But an engineer.
Is that how you thought before you went into school?
Not as much. Not really as much as that forward thinking. I don't think so. I don't think I was that logical. I think I got the skills more as I was going through the program and trying to be able to solve problems and figure out how to do it. That's what I mean, maybe that's what it did, is it honed my skills to be able to do that. I got to tinker around a lot. I should have been a civil engineer because when I used to, my parents are from Belen. So when I used to go to Belen to stay with my grandparents, they would irrigate, and it was great because I would go out in my little cars. I'd wake up, I'm a morning person, so I wake up with my grandfather at 4 o'clock in the morning, and he would, start the irrigation and the water through. What I had done is I had built these little cities around the irrigation, so I had bridges going over where the water was going through, and I had built roads, and I had all my Lego houses and all my stuff around there, so I loved it when he would do that because I'd go out there and play. And then I became the Calvin and Hobbes kind of thing where the cars crash in the water and people die and you do all that stuff. So that's the kid in me. But that's the stuff that you kind of figure out what it is that you want to do. So.
Do we have a 3D printer at UNM?
Yes.
Is it pretty cool?
Yeah, it's really neat. It's actually in the mechanical engineering lab downstairs. Yeah, it's a really neat machine. Very expensive, but yeah, to run it. But yeah, they have a 3D printer back there. Okay, well, I have a bunch of stuff up here for you. I've got our School of Engineering brochure, which gives you information about all the programs. The degree programs, which are the curriculum sheets, which tell you what you should be taking. If you go to STEM Up, they've actually taken our sheets and tailored them to CNM to say what you could do in 4 years to finish up. Why you want to be an engineer at UNM, our ESS brochure, and then my card. And if you want to contact me, please don't hesitate to do that. So, okay?
That'll help you with your project. Semester project, so.
That's right. And then I promise you, if you become a Broncos fan, that's going to make you one of the smartest ones in class. Because next year they're going to win it all. Okay.
Well, thank
Thanks.
you.
Okay.